Alex provides rapid, lifelong machine learning solution development and operational management. It helps you to automate predictive models for millions of objects without having special data scientist expertise. First of all, you should get accustomed to two main logical entities of Alex, which are an AI project and an object group. An object group, such as smart buildings, contain objects with their attributes. Every object shadows a real-world entity and tracks its attributes in real time or near real time. Alex supports a full set of protocols to connect to data sources, and it supports billions of objects that profiled in real time. All thanks to proprietary in-memory DB technology. Let's take a closer look using an example. Diabetics type 1 object group. Every patient in this group is addressed by email, and every patient can have a huge amount of attributes such as glucose measurement, last insulin injection, average insulin injection, and so on and so forth. Some attributes look sophisticated. They are automatically generated by Alex using auto-feature generation capabilities or manually added by a domain expert. Data from object groups can be used for data-driven modeling. In our case, it is achieved by creating an AI project. Every project has a target, what to predict. For example, energy demand, glucose level for a patient, or a fault. Alex automates machine learning models development. It automatically adjusts required pipelines of algorithms and their parameters based on data from object groups. Since streaming data is changing over time, Alex will automatically reconsider the best algorithms and their parameters if need be. When a good model is found, Alex can use it to execute actions. For example, it could command to change energy distribution. In this demo, we'll focus on how to create a streaming AI project. We'll create a project that predicts energy demand for a smart building in 1 hour. We need to complete several steps. First of all, setting a name. Then we need to select that we're gonna use streaming data and smart buildings object group. A learning moment defines when a new data point is used for training a model. In our case, we choose every event that brings energy measurement data. Would like to use all available data features coming from object attributes for smart buildings. We also choose time-aware modeling since we need to predict using relative time, in our case, in 1 hour. A little bit later, we'll consider how features for object groups are extracted. After final checks, we can approve this project. Now we need to create a prediction model as such. We choose a target value feature that we'd like to predict. In our case, that is energy measurement value kilowatt per hour. Since we haven't pushed data yet, we need to select a type of prediction manually. Regression is about predicting a value. That is what we need. We can also change a metric to optimize. If we don't care, then we can leave it by default. At the next step, we can adjust some additional settings that are quite clear to follow. The most important thing we need to change here is the data filter. Actually, by choosing data points per profile, we tell Alex to automatically create an individual model per object in the object group. If we have 1,000 smart buildings in the group or 1 million patients, Alex will handle this automatically. In our case, we expect Alex to create 3 models, 1 per smart building. We need to wait for some time while these models are created. The first state of every model is collecting reference data. It means that a model needs more data points for the train. So let's see details of a model for Smart Building Mall 002. It's in collecting data state, but we haven't provided this data yet. After getting the data, it will proceed with hypothesis selection and training to build automatically the best machine learning model for the given data. We're going to send data for this object now. For the sake of simplification, we will use a CSV file. The data in these files is very simple. It contains the building's identity, timestamps, and simple values with energy measurement. We'll put the file in a folder watched by Alex so it can process it. Alex is configured to read this data gradually so we can see several learning iterations during the demo. Alright, so the model collected enough data points to start the hypothesis selection process in order to find the best pipelines of algorithm that predicts energy value in 1 hour based on learning data. We can see the model adjusting. There are regression analysis metrics. Let's see how they change over time as new data arrive. The metrics have clarification hints for easier interpretation. For example, r squared has a value between 0 and 1. The closer to 1, the better. Here we can see that this metric for our model is very good. We can also view some additional information about the model, such as basic information, how the number of learning points grew in time, how much time did it take to train the hypothesis, and very valuable information about feature importance. What features contribute to the prediction of the target value the most? In our case, energy value 1 hour ago, hour of a day, and day of week have the highest importance rate. Also, we can extract technical information about the best pipelines, meaning what algorithms, what transformations, and what parameters give the best results. Since the model is ready, we can enable a REST endpoint to use it for prediction outside Alex. And we can also view history, what's going on with this model during its life. Okay, on this screen we can see that only mol002 has been trained. The other 2 models in the project are still waiting for training data. Now let me show you one more entity that is called prediction context. Prediction context encapsulates a machine learning model and can be used by Alex workflow engine as a condition to execute actions. For example, let's define a prediction context that uses several intervals of energy values in the future. We can also use names for intervals. It allows us to create easy-to-read rules. For example, if energy value is high, then Alex will trigger an action that will distribute more energy for this building. We can also assess the model's quality visually using dashboards. Here we can see an example for the other 3 smart buildings, and we can visually see the difference between real and predicted values on these charts. Getting back to feature extraction, features can be configured via Excel-like formulas. Good news that Alex can automatically generate such formulas. It uses auto-feature generation capabilities. It generates only those features that are important for a given model based on raw data. If need be, a feature can be configured by a domain expert manually. One more point to mention is Alex's model's operation capabilities. Let's see this example of a power fault prediction model. For every project, we can create multiple model versions that may have, for instance, different features. They compete with each other, and we can see a leaderboard and what model version was the best at a given point of time. Here's what Alex gives you in a nutshell. Rapid model development, lifelong auto ML on streaming data, auto models which are perfect for IoT, operations capabilities. It is all about the great automation of intelligent processes.